Welcome to EDU World Space.
All right, let's go ahead and do this problem. So we are given an integral, and we're supposed to find the derivative of this expression with respect to x using part 1 of the Fundamental Theorem of Calculus. So to do a real quick recap, it basically boils down to the fact that taking the derivative of an integral basically undo each other. So if you have an expression that looks like this, what I want you to see that the variable used for the integration part is t, but you're plugging in an x. This makes it into a function of x, as you can see over here. So it's just that the relationship between large f and small f right here is that small f is the derivative of large f, or you could also say that the antiderivative or the integral of small f is large f, okay? So if you take the derivative of large f of x, it just ends up being small f of x. So from the point of view from here, what it looks like, it just seems like the integrand and the dt just disappeared, and instead of a t, now you have an x. Okay, so this is the most straightforward way that you would do this problem. So you would have to still deal with situations such as the product rule, the quotient rule, the chain rule, because you're still taking a derivative. But when the input is simply x, you don't have to worry about that portion. So you can just think of it as canceling out the integration. So let's apply it to this problem. If you take the derivative with respect to x of the integral from 0 to x of a function that takes this form, t plus t cubed inside the square root, where the variable is t, okay? We know that the integration and the derivatives are going to undo each other. And let's remember that the x is the input that makes this into a function of x. So the result just ends up being x plus x cubed inside the square root. And that's all you need to do.